Alright, so now you're just going to be doing a lot of practice. Nothing new now. Well, until after the quiz. Then we'll learn new stuff. Okay, so first I want you to find the derivative of h of x. Notice that you have three things multiplied together, right? So we're going to have to do product rule. So how does that work? Well, in this case, if I think of this as h of x is, let's give each of these a name. So I'm going to call this f and this g and this w. So h of x is f times g times w. So then h prime of x is going to be f prime times g times w. Oops. Plus f times g prime times w plus f times g times w prime. So I want you to go ahead and do that. Pause the video. Unpause when you're ready to check. Alright, so this one gets a little messy. But h prime of x is going to be the quantity x squared minus 2x plus 1 times the quantity x squared minus 7 to the 1/3 over 2 root x plus 5 plus root x plus 5 times the quantity 2x minus 2 times the quantity x squared minus 7 to the 1/3 plus root x plus 5 times the quantity 2x cubed minus 4x squared plus 2x over 3 times the quantity x squared minus 7 to the 2/3. Don't simplify. Just leave it. I mean, yeah. So how did I do that? I actually ran out of space. So here is the derivative of f, and then times the g and the w. So that's why, again, look at this teaching. Color coding, which ones I did the derivative of, and then the black is what I did not do the derivative of. So that's f prime times g times w. For f, I had to use the chain rule. Then f times g prime times w. For g, I just had to use the power rule. And then f times g times w prime. And then for w, I had to use the chain rule again. Then I just rewrote it without negative exponents, really. Any questions? Alright, moving on. Next one, find h prime of x. Pause the video, unpause when you're ready to check. Alright, so here we should end up with h prime of x equals 5/3 times the quantity root x plus the cube root of 2x, all to the 2/3, times the quantity of 1 over 2 root x plus 2 over 3 times 2x to the 2/3. How do we get that? Chain rule. So bring down the 5/3, subtract 1, and that becomes 2/3. Times the derivative of the inside, the derivative of root x is 1/2 x to the negative 1/2. The derivative of the cube root of 2x is 1/3 2x to the negative 2/3 times 2. Then I just rewrote this part without negative exponents. That's it. Moving on. Find the second derivative of f of g of x. So this is just in terms of generic functions. Think about the fact that the derivative of f of g of x is f prime of g of x times g prime of x. Pause the video, unpause when you're ready to check. Alright, so we should end up with f double prime of g of x times g prime of x quantity squared plus f prime of g of x times g double prime of x. How do we get that? Good question. Well, I told you right before I paused, or right before you paused, because you did, that the first derivative of f of g of x is f prime of g of x times g prime of x. Remember, that's our chain rule. So now I have a product. What? Product rule. Good. So then second derivative, product rule. So I did the derivative of the first, which is f double prime of g of x times g prime of x, because remember, all I'm doing is the derivative of the outside, inside stays the same, and then times the derivative of the inside. And then to finish off the first part of the product rule, then it's just times the second. So I did the derivative of the first times the second plus the first times the derivative of the second. Well, the derivative of g prime of x is g double prime of x, right? That's it. You don't overthink it. You don't know what the function g of x is, so you're just denoting that the derivative of g prime of x is the second derivative of g of x. Then the only thing I did to simplify was I have g prime of x times g prime of x, so I can write that as g prime of x quantity squared. It's very important that we have the quantity there because we're not squaring the x. Moving on. Find y prime. Pause the video. Unpause when you're ready to check. Alright, so here we should end up with negative 2 times the quantity 3x squared plus 1 over 3 times the quantity cube root of x cubed plus x to the 5th. How do we get that? Well, the first thing we do, and I know you did this because you did not use the quotient rule here. You didn't, because I told you don't. This is one of those examples where I said do not use the quotient rule here. If you did, you can still get the right answer. You're doing more work and causing more chance of error. So first, just rewrite the function as x cubed plus x to the negative 2/3. Now we just do our chain rule. Bring down the 2/3, x cubed plus x, subtract 1, so that's negative 5/3, times the derivative of the inside. There we go. That's it. See? Don't do the quotient rule. And I know you didn't, but I'm just upset about the thought of somebody doing the quotient rule. I don't like to be upset. It makes me sad. Alright. So here, you are given y equals f of x with f of 1 equal to 4 and f prime of 1 equal to 3. So I want you to first find g prime of 1 if g of x is the square root of f of x. Find h prime of 1 if h of x is f of the square root of x. And see what you get for those. Hint, chain rule. Pause the video. Unpause when you're ready to check. Alright, for g prime of 1 we should get 3/4, and for h prime of 1 we should get 3/2. But how do we get that? Okay, so if g of x is the square root of f of x, then I have the chain rule where the outside function is the square root function and the inside function is this f of x function. I don't know what f of x is, but that's okay. That doesn't mean I can't find the derivative of it. The derivative is just f prime of x. That's it. So the derivative of g of x is going to be do the chain rule. So derivative of the outside, bring the 1/2 down, inside stays the same, subtract 1 from the exponent, times the derivative of the inside, so f prime of x. I simplified a little bit, so this becomes 1 over 2 root f of x times f prime of x. But now I'm trying to find g prime of 1. So I know, so then I plug in 1. So f of 1 is 4, and f prime of 1 is 3. So I end up with 1 over 2 root 4, but root 4 is 2, 2 times 2 is 4, times 3, 3 over 4. Similar idea for h of x, except now the root is on the inside. So now the outside function is f of x, and the inside function is the square root of x. So the derivative of h of x is going to be f prime of root x, because it's just the derivative of the outside, times the derivative of the inside, which is 1/2 x to the negative 1/2. So I can simplify that if I want. F prime of root x times 1 over 2 root x. So now find h prime of 1. F prime of root 1. Well, root 1 is 1, so then f prime of 1, remember, is 3. And then 1 over 2 times root 1, but root 1 is 1, so this is just 1 over 2, so I have 3 times 1 over 2, which is 3 over 2. Alright, so again, I want to emphasize, it's really important to understand that when we have just a generic function, like f or h or g, and I say find the derivative, all you do is just put a prime there. That's the derivative. Don't think you have to know exactly what the function is to find the derivative of the function. Not true. Alright, so this is going to be similar to the problems we did on the notes from last night, I believe, where, okay, I have this graph of this function m of x and this graph of this function n of x. I want to have some composite function h of x that is n of m of x. So we want to evaluate h prime of x equals negative 2, h prime of x equals 2, h prime of x equals negative 1, and h prime of x equals 1. So what we're trying to do is find an x value that will make those statements true, knowing that h of x is n of m of x. So think about what is h prime of x, and think about using these graphs, when would that be negative 2, negative 1, 1, and 2. So all you're looking for is a value of x that makes this statement true, or this statement true. There are many values of x. So I'm going to have you pause the video and find some, but when you see my answer, I'm going to give you the range of values that you need to be in. Alright, so pause the video, find a value for each of these that makes it true. Okay, so if I have any value of x between, or that is greater than 25 but less than 50, then h prime of x is going to equal negative 2. If I have any value of x where x is greater than 50 but less than 75, h prime of x is going to equal 2. If I have any value of x that is greater than 0 but less than 25, h prime of x is going to equal negative 1. And any value of x greater than 75 but less than 100, then h prime of x will equal 1. So again, you did not have to come up with these ranges, you just needed to have a value within those ranges. How did I come up with those though? So first I thought about, okay, well if h of x is n of m of x, what is h prime of x? H prime of x is n prime of m of x times m prime of x. So now I need to identify a couple things on the graph first. Okay, the slope of m of x is negative 2 between 0 and 50, and it's positive 2 between 50 and 100. That's important. The slope of n of x is 1 between 0 and 50, and it's 1/2 between 50 and 100. Notice that both of these are not differentiable at 50. Okay, so now all I would do is I would just pick a value to start. So just guess, just pick some value and see what happens, because that's the only way you're going to be able to figure this out. So let's just say x is 10, okay? So if x is 10, then I need to figure out what is m of 10. So when x is 10, m is somewhere up here close to 80. So then the problem becomes, what is n prime of 80? So what is the slope of the n of x graph when x is 80? That's 1/2. What is m prime of 10? So what is the slope of the m graph when x is 10? That's negative 2. So I end up with 1/2 times negative 2. What's 1/2 times negative 2? That's going to be negative 1. So I picked x as 10, and I got an output of negative 1. Now, with, again, a little more trial and error, or guess and check, you're going to start to see that's how I came up with this range. Because as soon as I pick something beyond 25, so let's pick 30, for instance. So what is m of 30? M of 30 is going to be somewhere here. So I don't know if it's exactly 40 or not, but the point is that it's definitely less than 50. So then I'm evaluating n prime when it's less than 50, which means that the slope is 1. So this piece is going to become 1, and m prime of 30 would be negative 2. So negative 2 times 1 is negative 2. So that's how I get a value here. So again, that's what you're looking for, is what values are going to give you an output for m that's greater than or less than 50. And that's going to happen on this side too. Notice that if I pick something that is between 50 and 75, then that gives me something less than 50, whereas if I pick something greater than 75, that'll give me an output greater than 50, and the output of m of x is the input to n prime of x. Okay, so this one, it comes with guess and check, but you should be able to get it. Alright, last one. Find the equation of the tangent line. Pause the video, unpause when you're ready to check. Alright, I'm going to talk fast because we're running out of time. This one should have been more straightforward. We should get y minus 2 equals 13/9 times x minus 2. How did we get that? Product rule and chain rule. And then we're going to plug in 2 for x to find our slope, which is 13/9, and we had the point of 2, 2, so we didn't need to find a y value. There we go.